Hello, and welcome to Associate Consulting and Associates presentation for the Fort McMurray Clearwater River Flood Mitigation Project. This presentation will go over the identified issues and detail the development of an effective design solution. ACNA believes this proposed plan achieves the goals set out during the proposal phase of the project. It is a design that is quantifiably effective, environmentally responsible, socially acceptable, and most importantly, economically viable.
The municipality of Fort McMurray is located in northeastern Alberta and is home to a population of approximately 66,000 people. The town itself is bordered by two main rivers, the Athabasca and Clearwater. The latter is the main concern for this project as ice jam flooding occurs, usually in the springtime when the frozen river starts melting. Since the town is located in a floodplain, during years of severe flooding, thousands of homes and residents are affected. The most recent ice jam flood in 2020 caused approximately $220 million worth of property damage and displaced approximately 13,000 people.
To help guide the solution design, ACNA developed 5 key project objectives for the client that the detailed design is expected to meet. First, the total capital cost should not exceed the strict $220 million budget. So this was derived from the insurance damage incurred by the recent 2020 flood in the lower town site of Fort McMurray. Second, the design must eliminate 100-year probable flooding. In other words, it needs to mitigate up to and including the previously devastating ice jam flood elevation of 250 meters in the Clearwater River adjacent to the city. Third, the detailed design will meet or surpass applicable regulatory guidelines using ACNA's technical expertise. Fourth, the dike system should be integrated among the community due to its proposed route along the scenic river shoreline. And finally, ACNA will minimize the import of fill by using native cut material from the open channel section for the embankment. Several channel design alternatives had been generated in order to firstly meet the second objective of an optimized flood reduction, and secondly, to work within our realized constraints. These included a mix of square and trapezoidal channel sections along with varying widths and heights. So trapezoidal channels were found to be heavily constrained by the steep cross-sectional grade of the hillside we were working with. Therefore, ACNA has finalized the design with a square section 20 meters wide by 6 meters high. This width and height has been iterated for a maximum channel drawdown to 247 meters and a 1 meter freeboard. The channel's route roughly follows the hillside contours and is about 1 kilometer long at 0.1% centerline grade. 2 HECRAS models have been run in the process of selecting a final channel geometry and route. These both achieve a 247-meter water surface elevation at the shoreline of the Clearwater River during the 100-year design flood event. Due to the seasonal nature of ice jam floods occurring in the springtime, the first model uses peak historical spring river flows along with a calibrated ice depth of 1 to 2 meters, depicting moderate ice jam conditions. The second model was run in order to observe conditions at a reduced river flow but ice depths of 3 to 4 meters. Fortunately, this model does not limit the solution and maintains a drawdown to 247 meters or less at more realistic ice depths. So pictured here on the right is a comparison of a 247-meter flood elevation in a HECRAS simulation with drone footage of the 2020 flood at approximately 247 meters as well. We can see that it is impacting mostly the shoreline infrastructure. For example, in the bottom right of the drone picture, there is a parking lot, boat launch, and city park underwater that we cannot see. At this elevation, water is just beginning to enter the lower town site at low points along the shoreline and road.
A concrete wing wall inlet has been designed to receive incoming flows from Clearwater River. Regional Municipality of Wood Buffalo standard drawings have been used and modified slightly to suit this very unique project. The proposed structure shall contain metal grating to prevent ice and wildlife from interfering with the channel's hydraulic performance. Beyond the concrete channel bed, The earth is graded downwards, as seen in the figure, and lined with Fleximat to mitigate erosion. Additionally, a cutoff wall will be installed to reduce seepage below the structure. The spill point is set to 242 meters in elevation, above which point the entire channel will become online. The second part of the proposed design is a 3-kilometer long dike system, stretching along the northern edge of the town. It is meant to work in tandem with the open channel, in an effort to prevent flooding to Fort McMurray. A top elevation of 248 is maintained throughout its entire length, providing a 1-meter freeboard above the new flood level of 247. The alignment of the embankments follows very closely to the edge of the river, with its height and width varying along its length. As you can see here, a vision for a multi-use trail has been incorporated into the dike system. This will give residents of the town an enjoyable infrastructure to walk or bike on, and adds further utility to the proposed design. Beyond the 6-meter wide trail, the embankment is to be graded down at a 3-to-1 slope for soil retention towards the existing ground. This design is really meant to complement the open channel, as the two will work together in their own ways to prevent flooding to the town.
The ACNA team completed a weighted decision matrix to determine the erosion control method. The team pulled their design objectives into the weighting of the design criteria, such as meeting the strict $220 million project budget and ensuring that the design is aesthetically and socially accepted by the local community. The erosion control method that scored the highest was a turf reinforcement mat in 2 of the 3 locations, and thus will be selected to be recommended at all 3 locations to ensure efficiency during the construction phase. ACNA is extremely proud to announce a solution that is below the $220 million budget without compromising performance. The overall estimated project cost is approximately $60 million and includes the following items as shown. The largest driver in cost is land acquisition, which accounted for 36% of the total estimated project cost and is located in miscellaneous costs. So, how well did we solve the problem? The team initially set out 5 objectives. The first objective was meeting a $220 million budget, and the team met this objective with the total estimated project cost of $60 million plus tax. The second objective was eliminating 100-year probable flooding. The team achieved a flood drawdown from 250 to 247 meters, with a 248-meter elevated shoreline embankment, meeting this objective. The third objective was to meet or surpass regulatory guidelines. The team referenced multiple sources, including Regional Municipality Wood Buffalo guidelines. The fourth objective was to integrate the dike embankment within the community. This objective was met with the design including a community trail for walking and biking. The fifth and last objective was to minimize import of fill and environmental disturbance. The team met this objective with 36% of the dike construction using native fill material, and the dike's footprint is clear of major existing infrastructure.
Associate Consulting and Associates strongly believes that the proposed solution outlined in this presentation will effectively reduce ice jam flooding in the town of Fort McMurray and save the town and its citizens millions of dollars over the long run. The ACNA project team would like to thank the following individuals and groups for their support throughout both phases of this project. Dr. Bruce McVicker for his consistent assistance and expertise during Phase 1, helping with data collection, and during Phase 2, assisting with open channel modeling and hydraulic calculations. Dr. Nadine Ibrahim for her constant support during both phases, helping the team stay on track and providing guidance on different aspects of the project. The Government of Alberta for supplying valuable river data used in modeling, and lastly, WSP Canada for providing surveys of the project site.